Hey everyone, and welcome to The Explainer. I am absolutely thrilled to have you here today because we're going to look at flying in a totally new way. When most of us think about commercial aviation, we immediately picture these massive jet engines, aerodynamics, and insanely complex computer systems. But today, we're going to see how flying is just as much about psychological engineering as it is about mechanical engineering. We're going to uncover the invisible forces shaping literally everything, from the pilot's split-second decisions to your own mood sitting right there in the cabin.
So, let's kick things off with a slightly weird but fundamental question that really shifts our perspective. Is an airplane just a vehicle, or is it actually a flying psychological laboratory? Because if we stop looking at the engines outside and focus on the human minds inside, well, it changes everything. The second those cabin doors close, every single person on board is thrust into a highly unnatural, high-stakes environment, and that environment tests the absolute limits of human cognition and emotion.
Here is our flight plan for today. 1. Aviation psychology explained. 2. Inside the cockpit. 3. The causes of air rage. And 4. Hacking the passenger experience. Let's get right into it.
Section 1. Aviation Psychology Explained. The Science of the Sky.
Think about it for a second. Hurtling through the sky at 500 miles per hour in a sealed metal tube is an incredibly unnatural act for the human body and mind. It's so bizarre, biologically speaking, that it requires an entirely dedicated scientific field just to make it work safely. And the history here is fascinating. Aviation psychology actually originated way back in the 1920s in the USSR, evolving right alongside aviation medicine. Because when we separate from the Earth, our bodies freak out a little bit. We experience a drastic change in spatial orientation, we're subjected to rapid accelerations, weird drops in barometric pressure, and even changes in atmospheric composition. All of these environmental factors take a massive toll on the human nervous system. So aviation psychology basically studies how to maintain uninterrupted concentration and rapid decision-making while dealing with these extreme biological stressors.
Moving right along to Section 2. Inside the cockpit, engineering the pilot's mind.
Now, to really understand this high-stakes world at the very front of the plane, we have to look back in history. We need to see how aviation experts actually engineered the pilot's mind to counteract our natural human flaws. Back in the late 1970s, the aviation industry went through a really dark period with a series of tragic, serious accidents. But when investigators dug into the root causes, they didn't find mechanical failures. They found human factors. We're talking ineffective teamwork, lack of leadership, poor communication, and just fundamentally flawed decision-making. So in response, the early 1980s saw the birth of a revolutionary training system called Crew Resource Management, or CRM. By the 1990s, this was so effective they expanded it to air traffic controllers and maintenance crews. And honestly, it's been so wildly successful that today it's actively adopted by other high-risk fields like the rail and marine industries.
And you can see just how deeply integrated CRM is today. Take Transport Canada's official best practices, for example. CRM is no longer just some neat, theoretical psychology concept. It is a fundamental, heavily regulated standard used by government agencies to ensure safety. It is, quite literally, the official rulebook for human teamwork in high-consequence environments.
So what exactly are they learning in this training? Well, CRM rigorously trains very specific cognitive skills. Pilots learn advanced situational awareness, meaning perceiving their environment, comprehending it, and constantly projecting what will happen next. They are trained in threat and error management to identify external threats like nasty weather, but also internal threats like their own fatigue. They also actively train to overcome something called automation bias, which basically prevents them from blindly over-relying on the aircraft's computers. By mastering group decision-making and hyper-effective communication, the flight crew's minds are engineered to act as the ultimate fail-safe against the natural flaws of how we humans process information.
But here is the absolute crucial takeaway. Human error is simply inevitable. Aviation regulators openly acknowledge that we cannot train away all of our biological limits. Some of our cognitive blind spots are just innate, they're hardwired. And that right there is exactly why aviation relies so heavily on engineered teamwork, shared mental models, and carefully designed human-machine interfaces. The goal isn't actually to make pilots perfect. That's impossible. The goal is to create a system that catches imperfections before they turn into disasters.
All right, let's step through the curtain for Section 3, the causes of air rage. Turbulence in the cabin.
So while the pilots up front are operating with this engineered precision, the passengers in the back are, well, sometimes they're operating on pure emotion. When researchers look into the primal triggers that cause people to act out in the sky, it turns out air rage might actually be a huge question of class.
There's this fascinating study by researchers DeSelles and Norton that found the literal physical design of an airplane highlights situational inequality. Think about it. When economy passengers board at the front and are forced to walk through the luxurious first-class cabin, it actually triggers primal fight-or-flight responses. The researchers basically describe the modern airplane as a microcosm of a class-based society. Just the simple subconscious act of perceiving this physical inequality significantly increases the chances of disruptive antisocial behavior. And that goes for people in both cabins. Crazy, right?
Aside from class anxiety, an Australian roundtable study identified some other major predictors of cabin turbulence. And interestingly, the predictable risk factors rarely have to do with demographics. Instead, it's all about the context of the trip, people traveling to party destinations, large groups like sports teams, and of course, intoxication. Those are your primary risk factors. But airlines are absolutely fighting back. To mitigate these risks, they use psychology. They provide frequent informational updates to calm anxieties. They'll actually contact employers beforehand to enforce codes of conduct for corporate groups. And of course, they implement very strict, responsible alcohol policies.
And speaking of alcohol, here is a really surprising biological fact that makes monitoring passengers incredibly tricky for flight attendants. The study notes that altitude can potentially increase the physiological effects of alcohol, even at much lower blood alcohol levels. So what does that mean? It means a passenger might seem totally, perfectly fine while boarding at the gate. But once that plane reaches cruising altitude, the physiological changes kick in, making their level of intoxication so much harder to gauge and manage.
Which brings us to our final stop, Section 4, Hacking the Passenger Experience, the Invisible Hand.
So airlines know full well that the cabin is basically a pressure cooker of biological stress and social anxiety. But they aren't just using rules and policies to fight back, they are using the invisible tools of architecture and light. For decades, airlines were stuck with these awful old fluorescent tubes. They operated on a simple binary on-off switch, generating this harsh, flickering glare that subconsciously heightened passenger fatigue and definitely triggered irritability. But today, aerospace giants have introduced modern LED mood lighting. These advanced matrices can produce millions of programmable shades, offering these super smooth, imperceptible tonal transitions that can last up to 30 minutes. And let me tell you, this isn't just interior decoration. This is weaponized neuroscience.
The real reason airlines are investing hundreds of millions of dollars into this lighting is to literally hack your circadian rhythm. That's the biological process regulating your sleep-wake cycle. The lighting designers are intentionally trying to control the production of two key hormones in your body. First, melatonin, which helps you relax and sleep. And second, cortisol, which is your stress and alertness hormone. By washing the cabin in deep, calming blues during boarding, or maybe warm honey tones right before a meal, they are actively manipulating your biochemistry to keep you calm and compliant.
But lighting is really only half the battle here. The other half is cabin neuroarchitecture. Just think about it. Enclosing a human being in a narrow, inescapable metallic cylinder is deeply, deeply unnatural. It immediately triggers an evolutionary, subconscious claustrophobia in our brains. Now, to combat this without reducing the number of seats, because let's be real, that would hurt the airline's profits, interior architects meticulously design the curves, the overhead bins, and the visual sightlines to visually expand the space. They are physically tricking your brain into feeling like you have way more room than they actually do. And that illusion makes the flight feel shorter and significantly more pleasant. So that brings us to the end of our explainer, and I want to leave you with a final, slightly provocative question. Next time you settle into your seat, buckle your seatbelt, and watch as those cabin lights slowly fade into a calming sunset orange, ask yourself, who is really controlling your journey? Is it the highly trained pilot up in the cockpit, or is it the invisible psychology of the plane itself? Thanks so much for joining me on The Explainer today, and as always, keep questioning the world around you.